Hey everyone, Professor Davis here from ChemSurvival.com and the YouTube channel ChemSurvival. And in this short video, I'm going to show you how to draw the Lewis structure of carbon tetrachloride, assuming that you already have a basic understanding of what Lewis structures are and how bonds form. Now, assuming that you understand that, we can go through a simple procedure to draw the Lewis structure of just about any small molecule that we encounter. To do this, we first count the total number of valence electrons in the entire molecule. Next, we'll put the least electronegative element in the center of that molecule. Then we'll bond all the other atoms to that central atom using a single bond or a sigma bond. After that, we'll fill the remainder of the atoms within that molecule using electrons from our budget, and we'll check to see if we have octets for everyone. If so, we're finished. If instead we don't have enough electrons, we'll have to consider pi bonds, and if we find we have too many electrons, we'll have to think about expanded octets. So let's use these rules now to draw the Lewis structure of carbon tetrachloride. I'm going to start by counting valence electrons. Now, in order to do this, I have to acknowledge that CCl4 has one carbon atom and 4 chlorine atoms. And a quick check of the periodic table tells me that carbon has 4 valence electrons and each chlorine has 7. This gives me a grand total of 32 valence electrons to work with in building my Lewis structure. So that's my budget of electrons. Moving on to step 2, I'm going to place the least electronegative atom in the center of my molecule. In this case, that atom is carbon. So my carbon atom will be central, and my chlorine atoms will be arranged around it like this. Step 3 tells me to create one bond between each peripheral atom and the central atom, creating a sigma bond network that holds the molecule together. My network looks like this. I've had to use 4 bonds to complete my bonding network. And of course, each covalent bond has 2 electrons associated with it. So I've used a total of 8 electrons from my budget, leaving me with 24 electrons to try to satisfy octets. Step 4 is to use what's left of that budget to try to give every atom in the molecule an octet. Now, in order to do this, I'm going to give each chlorine 3 more pairs of electrons. So now each chlorine has got 6 non-bonding electrons that I've given it, and that means a grand total of 24 electrons were used to do this. So I've depleted my electron budget. I've finished step 4, and the only job I have now is to review my structure and see if I've managed to satisfy the octet rule for everyone involved. Let's take a look at the chlorines. Each chlorine atom in my molecule has 6 non-bonding electrons and 2 bonding electrons. All of them believe they have an octet, so they're happy. The carbon in the center has 4 bonds to it with 2 bonds per electron, and therefore also believes that it has an octet. Therefore, the carbon atom is also happy, which means that all the octets are satisfied and I'm done. I don't have to consider pi bonds or expanded octets in this very simple example. So in a very short time, using a very systematic method, we've been able to draw the Lewis structure of carbon tetrachloride. Next time we'll take a look at some examples in which we do have to consider pi bonds and expanded octets. But for now, we've accomplished our goal of drawing the Lewis structure of carbon tetrachloride. Thanks for watching, everyone. I'm Professor Davis from ChemSurvival.com and the YouTube channel ChemSurvival. See you on the next video.